Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today to study the relation between the force and the distance between the two charges. What will happen to the force if the distance between the charges increase, and what will happen if the distance between two charges decrease? Let's start with the equation. The equation or the formula for the Coulomb's law, it's F equal K Q1 Q2 over R square. F equal K absolute Q1 Q2 over R square. As you see from this formula, if the distance increases, the force will be decreased, and vice versa. If the distance decreases, the force will be increased. But there is square in distance, so that the force is inversely proportional with squared R. What it mean? It mean if the distance is double, it means double 1 over 2 square, the force will be 1/4, 1 over 4. If the distance is halved, 1 over half the square, 1 over half square, it means the force will be 4 times. And this relation, we can write it, the formula like this. F2 over F1, it's equal R1 over R2 square. And we can substitute in this equation to find the answer exactly. We have a question number 38. Two charges are separated 8 centimeters. Two charges are 8 centimeters apart. We have two charges. This is charge number 1 and the charge number 2. There is repel between the two charges, Q1 and Q2, and the distance between the charges is 8 centimeters. They are moved closer to each other. We take the same charges and move these charges closer to each other. Exactly, the force will be increases because the charge move closer to each other. We moved closer to each other enough that the force on each of them increase 4 times. Suppose the force in case number 1, it's F. When we move the charge close to each other, the force increases to be 4F. Case number 1 and case number 2, after the distance changes between two charges. How far apart they now? We need to find out the distance, the new distance equal what? The first distance, the initial distance at 8 centimeters. We know F2, the force in case number 2, over F1, the force in case number 1, it's equal distance number 1 over distance number 2 squared. Force number 2, it's 4 times force number 1 over force number 1, it's only 1 F. What about distance in case number 1? The distance, it's 8 centimeters. And the distance number 2, we don't know, it's unknown, squared. Now we can cancel F with F. How many unknown in this equation? It's only one unknown, it's R2. We can use shift solve using the calculator, or we can solve it mathematically by take the root in both sides and solve it by mathematics rule, or use the calculator like that. 4 over 1 alpha equal squared, then fraction 8 over x unknown. Shift solve equal, the answer is 4. So that the distance number 2, it's equal 4 what? 4 centimeter. Why centimeter? Because in given the distance by centimeter, the answer will be centimeter also. Okay? Or you can take square root, it will be 2 equal 8 over R2, and substitute the R2 will be 4 centimeter. Question number 2. Two charges, object experience a mutual repulsive force 0.1 Newton. We have two charges, charge number 1, charge number 2, and there is repulsive force 0.1 Newton in both sides, Q1 and Q2. If the charge of one of the object is reduced by half, we make a changes. First charge at 0.5 Q1, we change it to half. Okay, there is any other change? Yes. And the distance separation of the object is double. Suppose the distance in case number 1, the distance is R1. It increases to be doubled. Distance in case number 2, it's 2 double of R1. Q2, the same, not changing. What is the new force between the two charges? We have two charges. They have repulsion force because the charges is the same, are the same, and the distance we don't know in case number 1, and the distance is R or R1, whatever. Okay, we make two changes. I change the value, the magnitude of one charge, we make it half, we decrease it to half, and increase the distance to double. What is the new force? From case number 1, we know F, it's equal K Q1 Q2 over R squared. This is Coulomb's law. In case number 1, F equal what? 0.1 Newton. Okay, equal K. Q1, it's Q1. Multiply Q2, also Q2. Over the distance is R1 squared. Great. Only we substitute. I substitute force with 0.1 and write K, Q1, Q2. In case number 2, the force we don't know, F2 equal K. Q1 in this situation, it's half. So that I write half Q1. Q2 is the same, remain the same, Q2 over the distance squared, the distance 2 squared or 1 squared. Only substitute. We have two formula, formula number 1, formula number 2. We can divide 2 by 1. So that F2 over 0.1, it's equal K 0.5 Q1 multiply Q2 over 2 squared, it means 4 R1 squared. Divide K Q1 Q2 over R1 squared. Divide, we can make it multiply and inverse the fraction after divide. We can make this multiply. I change this to multiply and reverse this fraction and make this fraction R squared R1 squared over K multiply Q1 Q2. We can cancel K with K, Q1 with Q1, Q2 with Q2, R1 squared with R1 squared. The final answer F2 over 0.1 equals 0.5 over 4. It means F2 over 0.1, it's equal 0.5 over 4. One unknown, shift solve, the easiest way to find the answer. Fraction unknown x over 0.1, alpha equal another fraction 0.5 over 4, shift solve equal answer is 0.0125. So that the force in case number 2, it's equal 0.0125 Newton after these changes. The charge decreases to half and the distance increases to double. The new force is 0.01 to 5 Newton. Next question, if the distance between two positive point charge is tripled, the distance in case number 1 it's r, and this distance is tripled. It's become what? 3r. There is a force F. When the distance increases, what will happen to the force? It will decreases. Okay, decreases to what? F2 it's equal what? I don't know. We write this force number 1 in case number 1. Okay, we know that F2 over F1 it's equal R1 over R2. Don't forget a square. F2 unknown. F1 named F1, we don't know what is the value. R1 it's R, R2 it's 3R. 1R over 3R. Don't forget what? Square. We can cancel distance with distance, so that force in case number 2 over force in case number 1 it's equal 1 over 9. What it mean? It mean force in case number 2 it's equal 1 over 9th force number 1. It decreases. It means the force decreases to 1 over 9th. Okay. It's also mean the force decreases by a factor 9. The same, the force decreased to 1 over 9th, or we can write it the force decrease by a factor 9. The same. I can say the force decreases to 1/9 or the force decreases by a factor 9. Okay, when the distance increases, the force decreases. The relation is inversely with square r, with a square distance. Thank you so much.